All right, today we're doing a real engineer's deep dive on a new piece of gear that's making some waves in the GNSS world, the Jumpstar G27SH smart antenna. Yeah, that's right. We've got the datasheet right here, and we're just going to tear it down spec by spec and see if the hardware actually lives up to the hype. Let's get into it. So, just looking at the datasheet right off the bat, these top-line specs are seriously impressive. This doesn't really feel like just another small incremental update.
I totally agree. It looks like a pretty big leap forward, especially when you look at the raw performance and the resilience features. So for me, the big question is, does the actual physical hardware match what they're promising on paper? Let's start there.
Okay, let's start with the outside and kind of work our way in. First up, build quality and how you'd integrate this thing into a system. Well, the first thing that just jumps out is this rugged housing. It looks and feels solid. I mean, this was clearly designed for being out in the real world, not sitting on a lab bench somewhere.
Exactly. And the datasheet backs that up with a standard IP67 rating. If you're putting this on a UAV or some agricultural robot that's out in the mud and rain, that's not just a nice-to-have feature, it's absolutely fundamental for reliability.
And checking out the I/O, that 7-pin aviation plug it's packed. You've got your standard power and ground, a couple of serial ports, but here's what's really important. They've included configurable pins for CAN bus and a dedicated PPS output. That pulse per second signal is so critical. Having that level of connectivity just shows you it's built to plug directly into modern vehicle control systems that need that super precise timing. All right, so the hardware is solid. Let's get into the guts of it, the core performance specs. Yep, this is where we see what this receiver can really, really do. Okay, first number, 789 hardware channels. I mean, that is just a massive number. It really is. What that means is it has the raw horsepower to track signals from practically every single satellite it can see across all the major constellations and frequencies all at the same time. That is a huge, huge advantage for redundancy. Next up, latency. The datasheet is claiming less than 10 milliseconds. And for something like a high-speed autonomous vehicle, that's everything. The delay between when the vehicle actually moves and when the control system knows its new position has to be almost zero. Sub-10 millisecond latency is exactly what you need for that kind of tight, responsive control. And of course, that super low latency ties directly into the update rate, up to 20 hertz. 20 position updates every single second. For a fast-moving drone or a robot, that gives you that incredibly smooth, continuous stream of data you need for stable, precise navigation. No jerky movements, just clean data. So this right here, this is what they mean by all constellation, all frequency. It's not just tracking GPS. It's pulling signals from Beidou, GLONASS, Galileo, QZSS, and across a whole bunch of different bands. And that's really where the robustness comes from. Let's say you're in an urban canyon and you lose a few GPS signals. No big deal. The receiver has this massive pool of other signals to draw from. It's all about holding on to that reliable RTK fix no matter what the environment throws at you. But raw performance numbers aren't the whole story. Modern environments are incredibly noisy, both electronically and, well, physically. Exactly. Which brings us to what might be the most impressive part, the receiver's intelligent protection and resilience features. And at the heart of all its defenses is this thing called AIM+, which stands for Advanced Interference and Mitigation. Right, and it's important to know this isn't just one single feature. It's an entire suite of technologies designed to protect the integrity of your position from all kinds of radio frequency threats. Okay, let's break this down. First, you've got AIM+. That's your frontline defense. It's looking for both intentional jamming and just accidental interference from other electronics. Then there's Lock+. Now this is a total game changer for any vehicle on rough terrain. Think of a mining robot or an off-road vehicle. It makes sure the receiver holds its satellite lock even when it's being shaken around constantly. And finally, Iono+, which uses some really advanced modeling to cancel out errors from ionospheric disturbances. So, when a solar flare messes with the atmosphere and warps the signals, this feature corrects for. So we've established that this thing has a highly resilient and super accurate idea of where it is in space. But for applications like robotics or UAVs, that's only half the battle, right? The next critical question is, how well does it know which way it's pointing? What's its orientation awareness? And the data sheet gives us a really clear answer. The G27SH supports a dual antenna setup specifically for heading. And get this, with just a 1 meter separation between antennas, it gets a heading accuracy of 0.15 degrees. That is incredibly precise. What that lets you do is have a UAV, for example, figure out its attitude without needing a magnetic compass, which, as we all know, is super susceptible to interference from the drone's own motors and electronics. This gives you clean, pure, reliable orientation data. So when you put it all together, the tough build, the high-performance core, all those intelligent defenses, and the precise heading, the question then becomes, where does a receiver like this really shine? I mean, what are the perfect applications for it? Well, the datasheet's own list of applications here makes perfect sense. The high update rate, the low latency, and that Lock Plus feature, that's a perfect match for UAVs and smart robotics, absolutely. And the all-constellation capability combined with Iono Plus is exactly what you need for something like precision ag or surveying, where you need to hold that consistent RTK fix all day long. And the dual antenna heading is a must-have for any vehicle-mounted precision control. The specs really do line up perfectly with what these fields demand. So I think our final verdict is pretty clear. This isn't just another component with a couple of cool numbers on a spec sheet. Not at all. It's the total fusion of that raw performance with this really sophisticated suite of protection technologies that makes the G27SH so compelling. It's been engineered from the ground up for those mission-critical systems that absolutely, positively cannot fail, where reliability is just non-negotiable.